first of all, it's a pleasure to be here. I will try to speak slow and improve my locution. And yeah, that's me. You can visit our website in English and Portuguese if you want to. It's been very interesting, this conference, and I hope that we can promote more conferences like that, globally speaking. And I have to say that I changed a little bit of my approach today based on what you have been talking yesterday. And actually, the crowd safety, probably I wasn't a little bit unhappy with this definition there, because actually it's a highly dense populated environment, let's say. Because when you think about crowds, we think about open space, and we are working with enclosures, just to differentiate. So can I just change it here? Well, just in case, everything is, we produced some photos, or photos with pH. Well, so basically what we are approaching this work is that travel distance, suggested by prescriptive codes, they might be not considered as design factor for enclosures where you have the population as an issue. You see that I'm very careful in saying might not be, probably because it's, it's how can I say, a hypothesis. This work we have done in 2010, and believe me or not, I haven't had time to publish it, so it's good to, I work as a consultant. Basically, I work installing sprinklers and smoke detectors and starting to do as well crowd modeling. And so it's a good opportunity to discuss about this work. Well, clearly, I think that the paramount word is performance. I think all of us here, we should believe that performance is paramount. And all these issues are very important, but I'll be concentrating on the time basis analysis, right? Well, clearly, human factors, for example, nightclubs, you have different kind of perceptions and awareness, people can be drunk and etc. What I'm trying to say is that although it's very important to talk about human behavior, we will concentrate only the relation between the people and the environment. And of course, I mean, you can discuss later, I know that environmental psychology is very important. You have many research that can be developed, so this can be something to be discussed. Human behavior, if you go into depth, you can even analyze the superego and ego, and this has an influence during evacuation time, depending on the circumstance. But we are not approaching that. I just want to make sure that we are aware of that. It's very important, but it's out of our scope of our work. Thank to Brian and Thunderhead and Sarah, Philippe, and Samuel for the support as well. Okay, so that's the content of our talk today. We will probably concentrate a little bit on the people movement models based on the discussion that we had, yesterday, and some of the results. As we said, crowds, we are not doing this kind of crowds. It's more enclosures. That's a big church in Brazil. And we have to think that, an enclosure like that should be, different the way we think about this and, let's say, an office, the way we define the travel distance. But before we start our talk per se, I would like to talk about this based on, the discussions today. Fire safety design, fire safety management, they are paramount. Modeling is just a tool. And we can use the model for both phases. We can use to improve fire safety design. We can use for doing a risk analysis, for example. We can use for the safety management afterwards. If I change the layout of my environment, how this is going to impact the relation that I have between me and the other people, and myself and the environment. So, modeling is a tool, just like a knife. A knife is a tool. I can, cut a beef. I can kill myself. It's just the way you use your tool. So, when well used, it can really help a lot. So in many cases, we have seen designs which either the guy used wrongly the model or neglected the smoke detection, sprinklers. So it's not a matter of blaming, let's say, modeling itself. And we have so much work that has been produced by NIST and FPA and SFP. It's worth to read this as well. Well, the UK regulations can be summarized like that. And I really believe that's a very strong and useful approach. Why? Because, for example, the ADB, which is for Wales and England, probably you guys know as well, is a prescriptive code, but it does give space in the very beginning for alternative solutions. As they say, fire engineering solutions or performance-based. So it's not only black and white. You can mix solutions with prescriptive and performance-based. And it's available. You have this document as well. But as engineers, this is very important. Engineers, architects, fire safety standards, they can be the best standard, but they will only bring, recommend minimal level of safety. And in some cases, the safety might be more complex. And that's where we as engineers, we should be always try to look beyond the black box. So that's very important. Not take this document, let's say, as a Bible and then follow. Sometimes, it might not be completely accurate. And the question, how safe is safe? It should be asked all the time, how safe is safe? If this building is mine, very likely we might have a different kind of perception. I will think twice, 3 times, or I will install sprinklers for sure. Yeah. So how safe is safe? If the document, can be a great document, but you should be always challenged that. Okay, so the relations, it's paradoxically speaking, I can also say that very likely many fire safety documents, prescriptive, they can be based as well on performance, you see. So performance theoretically based on unknown relations, such as the occupant, the relation between us and the built environment, and also between us, all of us, and the external stimuli. How I can, interpret, let's say, the strobe or the signs and the fire, the temperature. This initial blah, 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 I think it's important because what I want to get is, performances should have this holistic approach. And this book, it's still, as we call in English, old but gold. And it really gives you a clear understanding on performance as a whole and how we should think about the design on performance. I'm saying that because we are now having this influence from the green building certificates everywhere. And, we emphasize comfort, acoustic comfort, thermal comfort, energetic consumption, and then we are neglecting fire safety. So we should take into account all these criteria, but have safety as the paramount basis of this. The reason why I'm saying this is that I will go after that. It's all of us that we work with modeling, fire modeling, evacuation modeling, active fire protection system, passive. It should be together and understand the design, a project as a whole, architects, engineers. Okay, I'll pass that. Yeah, that's what you're saying. Our work will be, although, as we said, human behavior is very important, we'll be concentrating on the relation between occupants and the built environment. All right, so basically, this study we have used this based on some of our work in the past. We have quite a few. Okay. Quite a few work published, journal papers. We have our thesis, in where we challenge, for example, the travel distance, requirement. And we believe that for highly dense populated environments, we shouldn't be using sometimes this parameter the way we have been used. So it's a paper that we have published. You can go to our website. You can download that and go into depth. So what we are saying is that forget about the time of detection, time for alarming, and pre-evacuation time, which is very important. We will concentrate on time to move. The time to move can be understood as a timeline of, breaking down into two small timelines. TSM, which is time to start the movement, right? Time that we spent during the movement. And TSQ is the time that we spent during the queue, you see? So if you think like that, we can understand that the population density will probably play a major role in these relations. There is a work you probably know very well, Professor Dirk Heibing. He says that faster is slower, and we are going to explain this later on. So summarizing, well, time to escape, let's say, just concentrating these timelines, is time spent during the movement and time spent towards the exit, the queuing, etc. We have, I think one of our colleagues here mentioned about DOE techniques, I think it was someone, and we have done a lot of optimization work based on the Flack-Reeves technique, which is a gradient-based algorithm, and also the PSO, which is a genetic algorithm, and then try to find the optimal place to find the doors. We have done many, many cases. It's also available as well. You can Google that. But basically, it's well known, but we found and we proved that, to have a door, let's say, in the middle, the wall, is worse for highly dense populated environments. And to have the door in the corner will actually improve your evacuation time performance. So we think that, when we increase the area of the arc towards the door, we will increase the congestion and decrease the flow rate, and then increase the evacuation time. Okay, so people movement models, as I call, then you can include evacuation models, pedestrian models, etc. I'm saying this because, you model the movement of people. It doesn't matter if it's an emergency or circulation. So you can use for fire safety engineering, you can use for urban planning, crowd safety engineering, etc. There is quite a lot of discussion on the LinkedIn about this terminology. Now I want to talk about this issue quickly as well, about the model itself. Well, any model, any function is attempting to represent reality. And we will always have that delta of uncertainty. That's clear. But if you have a good model, validated as our colleagues have been discussing and checked and everything, and if you have the understanding about the phenomena that you are modeling, we can reduce that delta, substantially. And that's our work as engineers, to look beyond the black box, for minimize this delta of error as well. So we have some more stuff published. So what I'm trying to say is that, you have, there's a expression in English that rubbish in, rubbish out. So it's not only, you have these whole protocols which are very important, but the understanding of the phenomenon itself, either fire or an evacuation or behavior, is one of the steps. Then you have to understand the model itself, and then you can model and interpret, just like statistics. You can use it for good or bad. So another thing as well, that we can limit our variables. Because if you consider many aspects, well, life is, if you think in a very metaphysical way, life is non-linear per se. A lot of phenomena are non-linear. We try to make it linear for make this easier, right? So if you have that the equation F is equal to m times acceleration, it's an equation which is incomplete, because it is other variables such as attrit of the air and many things, but it works well. If you have an understanding of that function, and if you insert good variables, you can work well. So what I'm saying here is make analogy is that how important is to include some variables or not. So this is something that maybe, as some of you researchers, try to think in a perspective as, in the commercial field, we might waste time of, let's say, trying to research how the ants behave, for example, and make an analogy. It's nice, but, but it's very virtual, and we have seen these kind of things happening, and people using this approach for doing real projects. And because of that, many engineers, they start to say, oh, these kind of models, they're mumbo jumbo, they don't work. And we understand that because, it lacks of credibility. So, analogy with optimization. To know, for example, the global minimum of a function, sometimes it can be impossible. And if you have many variables, but if you try to restrict, okay, your constraints, you can find a local minima, which can be okay as well. So, something here that I've been also seeing, especially in the financial field and engineers as well, talk about Monte Carlo simulation. Well, you can use Monte Carlo, it would be okay, but Monte Carlo, if you think about a design space like this square here, let's say you have your variables x and y, ideally you should have your combinations or your points distributed along this design space. But Monte Carlo doesn't define that. It might pick up these combinations in the design space, distributed or not. So once again, increasing more uncertainty. So, okay, anyway, so the model to have used for this work is the Pathfinder. Is a well-known model. It's well built, validated. So you guys all know them, this model. And there are documents which, what we have been talking here, this theoretical approach, there's a document also in Britain that we helped to develop, explain that we can use evacuation modeling and as well fire modeling for, doing what we have said before, help to develop the fire safety design or do the analysis for the fire safety management. So they are tools. They are tools. Okay, so let's go to our theoretical work. Basic. Really? Gosh. Okay. Jesus. Okay, I'm going to speak now. Okay, so I have two scenarios here, 1 and 2. It's a very simple case. We populated there, crowded, and we want to check how the door's location would impact the performance of the evacuation. So that's the scenarios here. It's just simple. You can go into depth on the paper. You have, the paper is explained better. So, but basically, we found this that, the place where you put the door in the middle increases the evacuation time. And in summary, what I want to just finalize is that the concept of the travel distance is based, in a general way, minimize the distance to the place of relative safety. Well, it works, but there is a variable that, depending on the case, the population density in a critical factor, it will completely impact this law, if I can say so. So we tend to think, let's say, that it's better to put in the middle because it's short, it's more visible, let's say. But actually, for crowded environments, it's better to have, spread so you can have people evacuating in a more ordinated flow. Well, so that's the paper. That's actually showing the importance of the RDBE, yeah? And modeling can be a tool for that. You can find more about this work as well on the thesis. Just to finish, you can just give it. If we ask to ourselves, in Latin, cor vadimus, where we are going in terms of the modeling process, I would like to take the liberty to propose or maybe mention that. That's the way I think. I might be talking, But fire safety or safety, I cannot distinguish that from comfort. So it's all the same. And we have this green building industry now, which is big everywhere, sustainability. And I think in a commercial perspective, if we unite ourselves and we can, for example, prove and convince or explain to clients that investment on fire safety, including modeling for fire safety management package, it's really beneficial for the environment. The reason why I'm saying this is that, okay, I'm gonna pass that just to finalize. Yeah, the reason I'm saying that is, you have these codes now which are requesting, for example, people doing simulation for air quality using as well thermal comfort, and they have been used very powerfully. And I asked myself, why? I mean, I started to do modeling. Now I'm more a consultant, but doing modeling in 2003. And I have to say, I didn't see much evolution in terms of at least evacuation modeling specifically into the commercial field. And I've been asked, why is that? And these guys from the energy environment and the BIM models, they are really doing well. And I believe because they are organized themselves. And probably we should look at what they have been doing for creating an association or create certificates and things like that. That's what I'm saying. Something just to finalize well, similar to what we have for the smoke detectors. You have to have this device certified, and then the contractor should install this, should be certified, maintenance. So something similar as well with modeling, I suppose. Okay, that's a very important cause. If you want more information, I do apologize for being quite quick. And everybody's quoting people here, and I think I should quote two philosophers from, they used to say that life is very short, there is no time for fussing and fighting, my friend. So I think we should be, fire safety and all these other building constructions, and architects, we should work together because it's a win-win situation. Safety is going to be promoted, and we can also make more business. It doesn't cause any harm. So, okay, thanks.
Thank you. Do we have questions?
You were talking about the location of the exit, and some of the location in the corner was beneficial in comparison to the exit being positioned in the middle of the wall, given that there was a high density. Did you look at the threshold of the population density that moved it from one place to the other? Was there a point at which the density was sufficiently low that the travel distance mattered?
So they could change there. Yeah, that's a very good point actually. Yeah, indeed. Towards the end, some people decided to change but
was there the density? So there was a point when. Sorry.
I got.
Was there a point when there was the population density was sufficiently low that there was no difference between the position of the exit?
Okay, yeah. Well, to be honest, with you, I have done this work in 2010 when I was still working in the UK. At some point, we have looked at that, and I guess I put this in the paper, and I can send to you as well. But there was certainly towards the end, but I didn't specify this data.
Okay, thank you very much,
Okay,
Rodrigo.
Thanks.